This video is for Michigan Virtual, Algebra 2B, Section 9.3. Put that at the top there. So this is all, I think 9.3 is all geometric sequences. So geometric sequences are when you have a list of numbers and to go from, say, the first term to the second term, so I'm just going to make one up here quickly. My first term is 2. For geometric, to find the next term, you're always multiplying by a number. So say I'm multiplying by 4. So my second term would be 8. And then I'd multiply by 4 again, and I'd get 32. And then I'd multiply by 4 again, and I'd get 128. I think I did that right. So for geometric, you're multiplying by the same number every time. For arithmetic, which was an earlier section, I believe 9.1, that would be when you're adding the same number every time. So this would be arithmetic. You're doing plus 2, plus 2, plus 2. So geometric, you're multiplying every time. In this 9.3 section, they also go over two types of geometric, recursive and explicit. So for recursive, the formula uses the previous term to find the next term. So your formula will have the previous term in it. So this says to find the second term, or this formula might look like this. Z sub n equals 3 times z to the n minus 1. So this n minus 1 means the term before it. So for instance, they tell you the first term is 5, and this is your formula. You would find your second term, which would mean n equals 2. So z sub 2 means you're finding the second term. I'd put a 2 right in here. So then I'd have 2 minus 1. So this would tell me that the second term is 3 times the term before it, or times the first term. So my first term was 5, so my second term would be 15. We'll look at an example like that in a minute. Explicit means it doesn't rely on the previous term. You can find any term in the list by just plugging in the n value that you're looking for. So for instance, if you're looking for the 10th term, z sub 10, you wouldn't need to know z sub 9. Oops, sorry. You could just go directly and find the 10th term. So here's an example of a geometric function. So some of the questions in your practice and on your quiz would look like this. They would give you the list of numbers and they would ask you, is it geometric? So remember, if it's geometric, you're multiplying by the same number every time, or sometimes you can think about it as dividing by the same number every time. So pretend you just were given this. I'm going to cover up what I wrote there. You might notice right away that to go from 12 to 4, I'm dividing by 3. And then if I divide 4 by 3, I get 4 over 3. If I divide 4/3 by 3, I get 4 over 9. So you might notice, oh, this is dividing by 3 every time. Or dividing by 3 is the same as multiplying by 1/3. Another way to think about this is for geometric, you're multiplying by the same term every time. So the way you would find it is take this term and multiply it by the term before it. So if I take 4 divided by 9, so I'm kind of doing the reverse. If I want to find out what I'm multiplying by, I divide by the term before it. So if I divide 4/9 by 4/3, I get 0.333, which is 1/3. And then if I divide 4/3 by 4, so 4/3 divided by 4, I get the same thing, 0.333. So then I know I multiplied by 1/3 every time to get to the next number. that is the definition of geometric. So I would say, yes, this is geometric. The other thing they might do is give you, so this, if I were writing the equation for this geometric series, I would say my first term is 12 and I'm multiplying by 1/3 every time. And then geometrics generally start at n equals 0. So if I have a 0, n equals 0, I'm going to substitute a 0 in here for n. So I would get 12 times 1/3 to the 0. Well, that's 12. That's my first term, so that works. If I substitute n equals 1 into this equation, I would get 12 times 1/3 to the first power. I would get 4, so that works. That's my second term. If I substitute n equals 2 into this equation, I get 12 times 1/3 squared, which is 12 times 1/9, which is 12 over 9, which is the same as 4/3, which is my third term. So this is how I write an explicit equation when I'm given the geometric sequence or the list of numbers. So I first need to find what I'm multiplying by every time. They probably called that R in your lesson. So R is what you're multiplying by every time. This is your first term. But to figure out your first term, you have to assume you're starting at n equals 0. Okay, so the other type of problems you might see is where they give you a recursive formula and they ask you to list a bunch of terms. So they give me the first term. R sub 1 means it's the first term. This is my formula for finding the rest of the terms. So R sub n equals -2 times R to the n minus 1. The n minus 1 is your clue that it's recursive. So if I'm finding R sub 2, that means my n is 2. So think about substituting a 2 in here and a 2 in here. So R sub 2 is going to be -2 times R to the 2 minus 1. So that's -2 times R to the first, or R sub 1. Well, R sub 1 is your first term, which is 18. So then it would be -2 times 18. R sub 2 is -36. So this is R sub 2. Okay, to find R sub 3, that means I'm going to put a 3 in here and here. If I put a 3 in here, 3 minus 1 is 2. So I'm going to have -2 to the R sub 2, which is the second term. The second term is 36, so I'm going to do -2 times -36. So it always uses the term before it. Okay. Another type of problem you might get is something like this. Is it geometric? So geometric means you're multiplying by the same number every time. So again, the way to check it is to go backwards. Take 215 and divide it by 185. When I do that, I get 1.162. Now I'm going to do it again. I'm going to divide by, I'm going to do 185 divided by 155. I get a different number. So right away, then I know that, ooh, sorry, I keep bumping my phone. I know that that's not geometric. So let's try this one. 216 divided by 180. 1.2. So that means to go from here to here, I multiplied by 1.2. So let's try 180 divided by 150. I get 1.2 again. So this is looking geometric. Let's check the last one just to be sure. 150 divided by 125. Yes, 1.2. Geez, sorry about that. So again, if I'm multiplying by the same number every time, then I would say, yes, that's geometric. This one, well, I can tell this one isn't going to be geometric because these numbers are all the same, but this one isn't. So this has got to be your correct answer there. Okay, last type of problem is when they ask you to find S sub 1, that's the first term, and R. So remember, R is what you're multiplying by every time. And then they tell you S sub 5 is 10, S sub 8 is 80. So here's what you want to think. You have a list of numbers. You know the 5th and you know the 8th. They're asking you to find S sub 1. And they're asking you to find the R, what you're multiplying by every time. So if you think, if I'm going from 10 to 80 and I'm multiplying by the same number every time, what I want to do is I want to say 80 divided by 10 is 8. And there's 4 numbers here. 1, 2, 3, 4. So if I do 8 divided by 4, I get 2. And if you try this, 10 times 2, I would get 20. Times 2 again, I would get 40. Times 2 again, I would get 80. So this is looking like 2 is my R. So this right there is your R value. That's what you're multiplying by every time. Now to find S sub 1, this is a little tricky because remember I said we want to start at n equals 0. So this is the equation we're going to start with. S sub n equals S sub 0, 2, that's my R value, that's what we just figured out, to the n. So now I need to find S sub 1, but in order to find S sub 1, I have to use my general formula here. I really need to find S sub 0 first. So I know, say I know S sub 5. S sub 5 is 10. So I'm going to substitute a 5 in here and here. So S sub 5 is S sub 0, 2 to the 5th. I also know S sub 5 is 10. So now I have this equation. Now this I can solve for S sub 0. 2 to the 5th is 32. So S sub 0 is going to be 10 over 32 or 5 over 16. So S sub 0 is 5 over 16. So that means my equation for this geometric series is this. Take 5/16 times 2 to the n. So if I want to find S sub 1, I substitute a 1 in here and here. So I would get that, which is 5/8. So this tells me S sub 1 is 5/8. So you should check it though. So I'm going to put 5/8 in here. And then I'm going to go to my calculator. I'm going to do 5 divided by 8. And then I'm going to times it by 2. And what do I get? Let's turn that into a fraction. I get 5/4. So my second term is 5/4 times 2. I get 5/2. Keep going, times 2 again. I get 5. Oh, this is looking good. 5 times 2 is 10. So I know that I did it correctly. So my first term is 5/8 and my R was 2. Okay, that is it.